Welcome back to Larry's Classroom. Today we're going to talk about powers or exponents. Power or exponent. X to the n. X is called the base, and n is the exponent. We got x for the base, n for the exponent. And what this means is we have factors of x. X times x times x on up to, we will have n factors of x. If n was 3, we would have x times x times x. This would be x to the third. If x was 2, we would have x times x times x. Oh, excuse me, got one too many there. If x was 2, we'd have 2 factors of x. If x was 5, the base is x, the exponent is 5, we would have 5 factors of x. X times x times x times x times x. So we will notice that our base is x. In every case, we have factors of x. X cubed, we have 1, 2, 3, x to the third. We often say cubed when we say x to the third. X to the second, or x squared, 1, 2 factors of x. X to the fifth, 1, 2, 3, 4, 5 factors of x. And for now, our exponent, n, is going to be a whole number. A whole positive number. Now, exponents can be negative, exponents can be fractional, but for now, what we're working on, we're only going to work with whole number, positive whole number exponent. Positive whole number for exponents. Start by doing a few examples. 2 to the fifth. 2 is our base, 5 is our exponent, so we're going to have factors of 2, and we're going to have 5 of them. 2 times 2 times 2 times 2 times 2. So base 2, all 2's. Exponent 5, 1, 2, 3, 4, 5. And that works out to be 2 times 2 is 4, 8, 16, 32. So 2 to the fifth is also equal to 32. And here we show how we calculated that. We're going to do another example. We'll do several examples here. I want you to get the feel for what exponents are, what the base is. This one is going to be 5 to the third, and we often pronounce that as 5 cubed for 3. There's our base. Well, that's going to be what our factors are. There's our exponent. That's going to be how many factors. So we have 5 times 5 times 5 times 5. Okay, 5 times 5. 5 is our factors. 3 are the total number. And that works out to 5 times 5 is 25 times 5 becomes 125. So 5 to the third, or 5 cubed, is equal to 125. How about another one here? 7 squared. Do you recognize what the base is? It's 7. You recognize the exponent? That's 2. So how many factors of 7 are we going to have? We're going to have 2 factors of 7. 7 times 7 equals, well, 7 times 7 is 49. So 7 to the second power, or 7 squared, as we often say for an exponent of 2, is equal to 49. We're going to do a couple more. 10 squared. Base 10 exponent or power 2. So we have factors of 10, factors of the base. 10 times 10. And we have 2 of them, the number that are in the exponent, or the power of 10 that we've chosen, and that's 100. Thirteen to the second power, or 13 squared. The base, 13. 2 is the exponent or the power. So we're going to have factors of the base, which is factors of 13. And we will have 2 of them. 13 times 13, there's 2. Factors of 13, 1, 2 factors of 13. 13 times 13 is 169. So here we're going to have some fractions. So we're going to raise some fractions to a power. Here's 2 over 10. So that could be reduced, but we're going to leave it 2 over 10. And we're going to cube that. So that means the factors are 2/10, and we have 3 of them. But being we multiply fractions just by multiplying across the numerator, or multiply times across the, and multiply across the denominator, this could also be a single fraction. 2 over 10, 10, 10, 3 factors of 10, and 3 factors of 2 in the numerator, which could be expressed as 2 cubed, or 2 to the third, over 10 cubed. 10 to the third. Which 2 to the third over 10 to the third well, 2 to the third is 2 times 2 is 4 times 2 is 8. 10 cubed is 1,000. One thousand is divisible by 8. No, it is not. Excuse me. It is not. We could reduce this fraction because, yeah, I think 1,000 is divisible by 8. Let's check my 8. Yeah, well, 1,000 is divisible by 8. It's 125 times. So we divide the. Let's do this. 8 over. We're going to reduce this fraction. 8 over 8. 1,000 over 8, which reduces to 1 over 125. Which is equal to 0.08. 0.008. Which is 8 1,000ths. As you can see here, we got, that works out that way, 8 1,000ths. Now if we'd have done this, if we had this 210 reduced, we got 1 over 5. And we cube that. 1 cubed over 5 cubed becomes 1 over 125, which is, you see that's the same thing we got here. If we divide that out, we get the 0.008. But if we took that same fraction, 1 over 125, and we wanted to express it like this here, well, 1 times 8 and 125 times 8 multiplied by a magic 1, or a fancy 1, 8 over 8, 8 over 1,000. So I'd say it's debatable whether it would have been advantageous to reduce this fraction beforehand. I don't know. What really matters is that you bring it into the needed form in the end. And really, this was a better form because we wanted to express it as both a fraction and a decimal. And this made it very easy to move from the 8 over 1,000 to the 8 in the tens, hundreds, thousandths column of the decimal. We'll do another one. Two-thirds, and we're raising that entire fraction to the fourth power. And we can raise a fraction, as I showed you in the last example, simply by moving the powers inside. We can put the fraction 2 to the fourth over 3 to the fourth. You see that we move this exponent into here and this exponent into here. And let's do some of this. 2 to the fourth, that works out to be 16. 3 to the fourth works out to be 81. No common factors between 16 and 81. So we cannot reduce this fraction to lower terms, but we can convert it to a decimal by 16 divided by 81, which the easiest way to do that is on your calculator. And then I'm going to round this to 5 decimal places because it goes on. This one repeats, I believe. 19753. And now to indicate that this is a rounded number rather than an exact number, I'm going to erase this here equal sign. I'm going to replace it with the approximately equal sign, which is kind of a wavy equal sign. So 2/3, we move the exponents inside. We raise the denominator and the numerator to the power of 4 separately. We got 16 over 81. We divided to get the decimal, which give us and then we, because it wasn't it was a repeating decimal, we rounded it to 5 decimal places, and we used the approximately equal sign. Raise it to power, the fraction we raised to the power. Then we also express it as a fraction, simplified fraction, and we express it as a decimal. We'll do one more of these. 9 over 20. And that whole fraction is raised to the second power. As we often say, we're squaring this fraction. And you probably know by now, you move the exponent inside to the denominator and to the numerator. 9 squared. 9 times 9 is 81. We've done the numerator portion. 20 squared, 20 to the second power, 20 times 20 is 400. And if we divide that out, we've expressed this fraction raised to the power as a fraction. No common factors here, so we can't reduce. If we divide the 81 by 400 in with our calculator, or by long division, whichever you desire to do, 2025. So we've expressed this fraction raised to a power as a single fraction and as a decimal fraction. Now we're going to raise some decimal fractions to powers. 3.1. And it's raised to the second power, or squared. Well, we can write that as 3.1 times 3.1. There's our base, 3.1. That's our factor. This is our exponent 2. 2 factors of that. And you'll note that we have 1 decimal place in this factor and 1 decimal place in this factor. When we multiply, we add up the decimal places. If we do the 31 times 31 as whole numbers, we get 961. But we have 2 decimal places here. So we got to move it back 2 decimal places to get 9.61. And it kind of makes sense that this 3 times 3 would be 9. These are a little bigger than 3, so we'd expect something a little bit bigger than 9. So there's another way to kind of keep track if you're doing things correctly. But you can see that if there's 1 decimal place to the factor and we raise it to the second power, we're going to get 2. And that's because we have 2 factors and we got to add up 1 for each of them. We'll do another one here. Another decimal, which we're going to raise to a power. We're going to raise it to the power of 3, which we often call cubing it. Well, first off, before we even go any further, we have 1 decimal place in here inside our factor or our base. We're going to have 3 factors, so 3 times 1, we're going to have 3 decimal places that we use in our answer. But we'll demonstrate that a little more clearly here. 0.4, there's 1 factor of 0.4 of our base. 0.4, there's a second factor of 0.4 of our base. And 0.4, and there's the third factor. 1, 2, 3. Each of them is a factor of our base. And you notice that, as we said, 3 times 1 decimal point, well, there's 1, 2, 3 decimal places. Now, if we do the whole number type calculation that we talked about before, 4 times 4 is 16, times 4 is 64, so we write down to 64. But we need to have 1, 2, 3 decimal places. 3 times 1, 3 decimal places, so we got to add a 0 here. There we have our 3 decimal places. 0.064, 64 1,000ths. This is the tenths, hundredths, thousandths place. So that, but like 4. This is the base, those are the factors. This is the exponent or the power, those are how many of them. A couple more of these, I guess. .03 to the third. Okay, how many decimal places do you think our answer is going to have here? 3 factors, power of 3, 2 decimal places in each, so that's going to work out to be 3 times 2, 6 decimal places, it sounds like. Let's express it as individual factors. 0.03, there's 1 factor of our base. 0.03, there's a second factor of our base. 0.03, there's a third factor of our base. And we have 1, 2, 3, 4, 5, 6 decimal places. Well, if we go 3 times 3 is 9, doing the whole number type of calculus, 3 times 3 is 9, times 3 is 27, so we're going to write this 27 here. But of course, you can see these numbers are all much less than 1, so we're not going to have a result anywhere near 27, because we have the 6 decimal places we have to account for. Well, we have 2 digits there. To get 6 decimal places, we're going to have to add 4 zeros. And I'm going to add 1 more for the whole number portion to help your eye focus on the decimal place. And if we look here, we have 1, 2, 3, 4, 5, 6. 6 decimal places, 0.0000027. Or what would that be? Tenths, hundredths, thousandths, 10,000ths, hundredths, thousandths, 10,000ths, 100,000ths. Looks like that's millions, 27 millionths. Yeah, if we express this as a fraction, it'd be 27 over 1. We have the 6 zeros, 1, 2, 3, 4, 5, 6. And we have the 6 places, 1, 2, 3, 4, 5, 6. Very small number. And we had pretty small numbers to start with. So we're going to do one more of these. I'm going to erase this piece, get it out of the way. Do one more of these type of problems. 0.2, raise to the 4th. How many decimal places are we going to have in our final answer? 4 times 1, there's going to be 4 decimal places. And that is because we have 4 factors of our base. We got 4 factors of a base, 1 decimal point in each, 1, 2, 3, 4 decimal places. So if we use the whole number method, 2 times 2 is 4, times 2 is 8, times 2 is 16. So we're at 16 over here. And then we have to make that to be 4 decimal places. We have 2 here, so we add a couple of zeros. Then we put our decimal places, 1 more 0 just to make it look nicer, I guess. So 0.0016 or 16 10,000ths. That would be because we have tenths, hundredths, thousands, 10,000. So if you put that back to a fraction, it would be 16 10,000ths. We're going to talk a little bit about the order of operations. We've talked about order of operations before, but we're going to expand it just a little bit. You remember, for first we had parentheses. And now we're going to add to that exponents. Or you can call them powers if you like calling them that. 3, we're going to multiply and divide. And 4, we're going to add and subtract. Now we had parentheses, multiply, divide, add, subtract for. We didn't talk about exponents because we hadn't covered exponents yet. And exponents are a type of multiplication, as you can see. So that's kind of why we put them where they are, where we do. But we've added one more item to our order of operations. And I think that's going to complete the order of operations. I can't think of anything else that goes into that. We're going to write down the little please, excuse. I don't think I spelled that right. My dear Aunt Sally. And sometimes you'll see them say, please excuse my dear Aunt Sue. Parentheses, exponents, multiplication, divide, same pass, left to right. Addition, subtraction, same path, left to right. Please excuse my dear Aunt Sally, or please excuse my dear Aunt Sue. I've heard it said that way also. Just a helpful memory aid in case you forget the proper order of operations. I'm going to erase that, but I'm going to leave this up here for now because we're probably going to be using it a little bit. Talk a little bit about some of the errors that can occur. Well, we kind of talked about this. 5 over 3, we're going to cube that. That equals 5 cubed over 3 cubed. And if I wrote out the factors, you'd see 5 3s and this is a 10. This is supposed to be a 10. Why did I put a 3 there? 10 cubed. You would see 5 factors of 3. You'd see 5 factors of 10. And let's go ahead and do that. Or 3 factors, I mean. 5, 5, 5, and 10, 10, 10. We want to remember that the fraction bar acts like a parenthesis, so we do that first and do that first. 5 times 5 times 5, 125 over 1,000. And if we divide that with our calculator, we would say 0.125. Now this fraction could be reduced because that's divisible by 25, that's divisible by 25. But considering we're thinking about decimal numbers, it's kind of handy to keep it in with a denominator. It's a power of 10. It's not an incorrect answer. It's not fully reduced. And whether we fully reduce or not sometimes depends on the context in which we're doing something. Numerically, well, this would reduce to 25, we're going to 5 over 40, right? 5 goes into 40, and that can be reduced more. 5, well, it's 1/8, which is kind of obvious by looking at that. This would be fully reduced, but so these are equivalent fractions. Numerically, they're exactly the same. Whether you reduce or not completely, sometimes depending on the context of what you're doing things in. We chose not to here, showed you here just to show you that it is equivalent. And another reminder on how we would do it with a fractional or decimal number. 0.004 times 3. 2 decimal places on the inside, raised to the third power, not times 3. We got 2 decimal places on the inside, we're raised to the third power, so we could go 4 times 4, doing the whole number type of multiplication or calculation. 4 times 4 times 4 is, 4 times 4 is 16 times 4 is 64. So we'd write 64 over here. And then we're going to have 6 decimal places. So we got to add 4 zeros, put our decimal place and add that 0. 1, 2, 3, 4. Let's make that a little easier to read. Again, 64 1/millionths, small number. And just as a reminder, this would be 0.04 times 0.04 times 0.04. 3 factors, 2 decimal places in each. 1, 2, 3, 4, 5, 6. And that's how we got our 6 places here. And the 3 times 2 from this thing is how we get our 6 places. So it's all consistent, but you want to remember to keep track of that. When you're doing fractions, we move the exponent in for the numerator and in for the denominator, calculate it out. Here we're showing how the factors lay out of 3 each, and so on. We're going to do a few more, probably a little bit more complex examples here, and I left these up here because we're probably going to, well, not right now, but at some point I think we're taking into account the order of operations. Well, I guess we always take into account the order of operations, but 2 to the 6th over times 3 to the 2nd over 4 to the 3rd times 5 to the 2nd. Now remember, this acts like a parentheses, so we do this stuff on the numerator and stuff in the denominator separately. So we're going to 2 to the 6th happens to be, put our fraction bar there. 2 to the 6th happens to be 64. And 3 to the 2nd, 3 times 3 is 9. 4 to the 3rd also happens to be 64. So we got a 64 here. And 5 to the 2nd, 5 squared, 25. Now what you notice, we took this problem and we did the exponential part. And see, the fraction bar acts like a parentheses, but when you find something in parentheses, you do what's in the parentheses. So we looked at that as parentheses, then we did what was in the parentheses. We did the exponent. We did the exponent. For the bottom, this was like a parentheses. We did what's in the parentheses. We did the exponent. We did the exponent. And we have one more thing to do because we still have a parentheses there. We would do this multiplication, we would do this multiplication, but also notice that we have a factor of 64 in the numerator and the denominator. Bang, we can cancel them out, replace each of them with a 1, which 1 times anything doesn't change the result. So what we have left here, we got 9 over 25. Now we've taken this somewhat more complex expression, we've reduced it to equivalent expression, which is fairly simple to see. And what are the factors of 9? 3 times 3. What are the factors of 25? 5 times 5. No common factors. That is in lowest terms. Just did that guy. 3 over 4. 3/4 raised to the second power minus 6 times 1/4 raised to the third power. Now we're going to be thinking about order of operations because we got exponents. We got exponents. Let's do the exponents first. Well, 3/4 raised to the second power becomes 9 over 16. We ain't doing nothing with the subtraction. We're working on the exponent stuff. Didn't have the parentheses offset the factors, but really doesn't show any actual operation that means anything in there. Just kind of, we're using them for a multiply here. 6. Now the 1/4, we raise that to the third power. 1 to the third is 1. 4 to the third is 16. 4 times, no, that's 64. 64. Now we have one number here. We have a subtraction. We have a multiply here. So we need to take care of that multiply. So we're not going to do anything with the 9/16, and we're working with. We got rid of the exponents. Now we're working on the divide, left to right. 9/16 is a divide, but we don't really have to do that because just writing it there is basically indicates it's done. Now we're going to make this. We're going to subtract. I'm going to put a little sidebar here. 6 times 1 over 64 is basically equal to 6 over 1 times 1 over 64. So if we multiply across the numerator and across the denominator, we end up with 6 over 64. So that's kind of what we're going to be doing, but we're going to draw a fraction bar, and we're going to factor the 6 while we're at it. See if we got anything to simplify. 2 times 3. And we got the 1 here, but that's kind of implied. And what's 64? That's 2 times 2 times 2 times 2. I think we're going to have 6 of them, I think. 2. 2 times 2 is 4 times 2, 8, 16, 30 half. So now we have this 6 times 1 over 64 expressed as a fully factored fraction. We notice we got a common factor here we can cross out, so we'll 9 over 16 minus, what's this, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 3 times 1 is 3. We have a 3 for our numerator. 2 to the 5th, 5 factors of 2 gives us a 32 in the denominator. Now we're down to a subtraction of fractions. What do we need to do? We need to get them in like terms. So you probably notice already that 9 times, 2 times 16 is 32. So we're going to use a multiplier of 2. And again, I call this 2 over 2 a fancy one. We didn't change the value, but this is how we get this in the same terms, because we need like terms for subtraction. So let's carry that. 9 times 2 was 18, and the 2 times 16 was 32. We're going to subtract from that the 3 over 32. Now we have like terms. We can just, well, there's two ways we can do it. Well, let's do it this way. 18 minus 3. Now it expresses a single fraction. But we're really just subtracting across the numerator. 18 minus 3 is 15 over the common denominator of 32. And, well, there are no common factors between 15 and 32. So we have reduced this guy here to this guy here. We did our exponents first, then we did our multiply over here. Now we did a simplification. Now we had two fractions. We put them into a common denominator. We did the subtraction across the numerator. A couple more. We're going to do some calculations with, instead of having whole numbers, we're going to have some decimal numbers. 0.2, that's squared, plus 0.3 raised to the third power, or cubed, second power squared. That's a subtraction here. Okay, we have exponents, which we do before. Parentheses come before exponents, but these parentheses have no operation inside them. They just have a number. I could rewrite this same fraction, put a fraction bar, 0.2, and put the exponent up here, plus 0.3, and put the exponent up here, 0.4, put the exponent up here. So in this case, there is no difference. We can just drop the parentheses. We have simply put these parentheses here to aid your eye in seeing what number the exponent applies to. So really the parentheses don't come into play for the order of operations here, because they're really just a visual aid in this case. There's no operation inside them. Anyway, I'm going to erase this piece because I want to put something else up there. Put another fraction bar. 0.2 raised to the second power is 0.2 squared. That becomes 0.04. 2 times 2, 4. 2 times 1 decimal place, 2 decimal places. Same type of thing here. This 0.3 becomes 3 decimal places. The 27. There you go, 0.027. Zero 0.4 squared, I raise the second power, 2 times 1, we have 4 decimal places, 4 times 4, or 2 decimal places, 16, 0.16. Yeah. And now we're going to have 1 decimal place inside times the 2 for the exponent. We're going to have 2 decimal places. 3 times 3 is 9. And to get 2 decimal places, there's 0.09. Now, looking at the order of operations, the fraction bar acts like a parenthesis. So we have a parenthesis here. we could actually, let's use another color. Let's visualize what the parentheses amount to here. And even here, when we did the exponent before this parentheses, we need to do what's in the parentheses. We could have done exactly that to put that parentheses, this implied parentheses, which did mean something. We could have put that up initially, and we got to do the things inside the parentheses first to clear the parentheses. So we've went one step towards clearing the parentheses. The parentheses is represented by the fraction bar here. So now the 0.4 plus 0.27, that becomes 0.067. This would be like 0.040 plus 0.027. And then our fraction bar here. And the subtraction now we do under here, the 0.16 minus 0.09 leaves us 0.07. So we now have reduced this original item to a fraction that looks like this, but we like to have a whole number in the denominator. We got to multiply this denominator by 100 to get a whole number. So we're going to 0.067 times 100 over 0.07 times 100. Now when we do that multiplication times 100, we move our decimal place 2 to the right is the easy way to do it. So we end up with 6.7 over 7. Now we have a whole number in the denominator. We have it's not an improper fraction because the numerator is less than the denominator. We would like to express that also as a decimal. And we will do that by dividing out with our calculator or long division, whichever you like to do. And this one also had to round a little bit, so I'm going to use that approximately equal to 0.9571. So this original, I'm going to erase these now because they weren't part of originally what I provided you. They're implied there. So this original thing, after we saw the implied parentheses, did the exponents that were inside the parentheses, then did the subtraction and the addition that was inside the parentheses, this original expression is able to be expressed as 6.7 over 7, or approximately 0.9571. We're getting down close to the end for the day. Got one more we're going to do, and then I think we'll call it a day. 1/2 minus 1/3 over, and we got a parentheses, or exponent, excuse me, times 1/2 plus 1/10, and another exponent. Now here's an important place to look at the order of operations. We got to do what's in the parentheses first. We can't apply this exponent to here, and this exponent to here, and this exponent to here, and this. We can't apply the exponent 3 to 1/2 and to 1/3, or the exponent 2 to 1/2 and 1/10, because they got to be applied to the entire unit. So we got to do the part in the parentheses first. Now here's where important to look at that we have an operation inside the parentheses. Before we just had a number. So basically when we just had a number in the parentheses was already done essentially. It was more set off to aid our eye rather than to indicate a mathematical operation. So we got 1/2 and 1/3. So we need a common denominator. Well, 6 is a nice common denominator for 1/2 and 1/3. So basically 3/6 is equal to 1/2 minus 2/6 is equal to 1/3. And we'll still leave the exponent there. And the same thing, that for subtraction we need a common denominator. For addition we need a common denominator. A nice common denominator between 2 and 10 is 5. 1/2 is equal to 5/10. And we did that by multiplying the top and the bottom by 5, or the numerator and the denominator by 5. And with tenths we're happy with. Keep the exponent up here. So now we haven't completed the operation in parentheses. We put the fractions within the parentheses into a common denominator, so now we can do the operation within the parentheses. Well, I'm going to leave the parentheses here for right now. 3 6 minus 2 6. 3 minus 2 is 1/6. And same thing here. 5 tenths plus 1/10. Well, that's 6 tenths. So now we're working our way down and add an equal sign, show that the next line is equal to the line above. Now we have done basically the parentheses thing. We're ready to apply the exponents to the fraction. Now, here's an example of why exponents is head of multiply and divide. These fractions represent divide. We've talked about that a number of times. But we want to do the exponents first. So we want to apply the exponents to the numerator and the denominator. And we want to apply the exponent on both of these. So we can say 1/6. Yeah, I want to write that a little bit differently. I'm going to put the dot for times this time because I've got the fractions separated. 6. Oh, I copied that down wrong. That's 10. 10. So now we've moved the exponent into the numerator, into the denominator. There's the exponent in the numerator, the denominator. I see how I got that backwards. I looked at this wrong. This is 6 here. 1 6 6 10. Okay, I got those swapped for somehow. Copied it down to above, but now I think we're right. 1 6 1 cubed 6. Yeah. So now we have moved the exponents inside, and now these parentheses no longer represent an operation or just to aid your eye in seeing what the exponent applies to. So we're ready to do the exponent step. Well, 1 to the third power is 1. 6 to the third power . I wanted this to be squared. Darn it. This is a 2. This is a 2. I wanted the ball to be 2, so I don't know why I put the third in. 2, 2, 2. Okay. Now we're applying the exponent. Let's apply it correctly. Let's get the correct exponent. And you notice even though I had the wrong exponent up here, didn't make a difference for doing what was in the parentheses. But now we found the common denominators, we did the subtraction and addition. Now we moved our exponents inside to the numerator and the denominator. Well, 1 squared is 1, 6 squared is 36. We're going to multiply that times 6 squared, which this is going to come out pretty easy, isn't it? 6 squared, 100. Okay. So these factors can cancel, so it becomes 1 over 100 or 0.01. Did I do that all right? Doesn't seem to match my example, but yeah, I think we're good here. 6, 3 and 2, subtract 1 6, 5 tenths, 1 tenth, 6 tenths. We got 1/36, 36 100ths. Yeah, nicely they canceled. Come up with a nice little easy result. So what do we find here?
We utilize our order of operations, and we've added the exponents in now because we know what exponents are about. We did the stuff in parentheses first. We did the we simplified and did the stuff in parentheses first. Then we did the exponents. We got to this thing here. Well, then we actually, after we moved the exponents inside to get rid of the parentheses there, another form to show how exponents apply to both the numerator and the denominator. Then we did the actual power exponentiation and ended up with, we didn't have no addition and subtraction at that point. We got rid of it. We did the addition and subtraction was inside the parentheses. So after we did the parentheses, there was no more addition and subtraction. We canceled some like terms here to make our multiplication simpler, and there we are. We've beat ourselves to death on working with powers and exponents, and that's probably good enough for today. Thanks for coming and listening, and be sure to like and subscribe. And until the next time, keep on learning.